appeared at 6 months of age when the first deficit was found. But there was another criteria that we needed to satisfy, which is that during this plateau, from 6 to 13 months, we did not want to see that species rise in concentration in the brain. And none of these 3 species satisfied that criteria. Instead, their levels increased 500 to 1,000-fold. So it did not seem to us as though any of the species that had been hitherto measured in 2576 satisfied our criteria for A beta star. Set out to identify a species of A beta which would appear at 6 months, whose levels would remain constant during that plateau phase, and whose levels would correlate with cognitive dysfunction. Then, after he identified a candidate, he would then purify it out of the brain, and then he would apply it to normal animals to see if it could reproduce the functional deficit that was in the original mice. This is the series of extractions that he developed to separate proteins into extracellular soluble, intercellular soluble, membrane-associated, and insoluble, and he performed tests of known proteins in known compartments to establish the fidelity of the fractionation procedure. And then he looked in the brains, and because we were interested in soluble extracellular proteins, he focused on that fraction, and he found a band that appeared on a Western blot whose molecular weight is 56 kilodaltons, which corresponds with the predicted molecular weight of 12 A beta monomers. And that appeared at 6 months, was not present at 5 months, and its levels remained constant from 9 to 22 months. And so that satisfied the second criteria that during this period of stability, we did not see the 100,000-fold increase in its levels. It also correlated with memory impairment with a nice R-squared of 0.65. And when he purified it out of a brain of an impaired mouse using tandem immunoaffinity followed by size exclusion chromatography, he was able to obtain a single band on a silver stain that had the appropriate immunological properties. And by mass spectrometry, Austin Yang showed that the only protein species present in this purified fraction was the amyloid beta peptide. Leonard Yuki's group at UCSF received some purified material and showed by atomic force microscopy that the particles are indeed spheroid, and not rather than tubular. And this antibody, A11, developed by Charlie Blade, which recognizes a variety of oligomers, not just A beta oligomers, but also tau oligomers, preoprotein oligomers, was able to recognize this particular oligomer as well as a few others present in the brains of 2576 mice. And in an 8-molar urea gel, this oligomer remains very stable, indicating that there's probably not a globular protein associated with it that's causing it to migrate at the high molecular weight. We can, however, break it down with hexafluoral isopropanol at increasing concentrations from 0% to 45%. This band begins to disappear. And in its place, you can see that tetramers and trimers increase, and ultimately you can see monomers increasing. And this is depicted here in the graph. So probably the simplest model, which we can derive from this, is that the 12mers break down into tetramers and trimers, and then ultimately those break down into monomers. But we really don't know the structure of A beta star, and we're only speculating that it's a 12mer. Finally, the purified band can be injected into the brains of young healthy rats, and in 2 different tests. One was an operant test, and one is the Morris-Water maze. I can show you the Morris-Water maze results. The ability to learn the position of the platform is unaffected. However, the ability to remember where it was the following day is affected in the group that received A beta star compared to the group that received the vehicle. If you take the same rats and examine them 10 days later without giving them any more injections, and you have them run a new maze, they are both able to remember the location of the maze by spending more time in the target quadrant. This work was done in the Kelly Gallagher's lab at Hopkins, so we sent her the purified A beta star, and then she and Ning-Teng Ko injected purified A beta star into rats at Hopkins and arrived at these results. Well, we believe that the A beta star impairs memory by inducing transient physiological but not permanent pathological alterations in the brain because the animals recover from the injection. It's more like a form of intoxication. Now, I'm going to change my focus a little bit away from A beta star and include some work about other forms of oligomers, the so-called low-end oligomers, dimers and trimers, and then this group of oligomers called adults, which was first named back in 1998 by Bill Klein's group. These are synthetic oligomers that have a heterogeneous population of size and presumably shape. Dennis Elko's group has been very interested in studying these low-end dimers and trimers. His group, along with Mike Townsend, have published some really beautiful papers with Dominic Walsh on these low-end oligomers. And I've talked